Bonjour, juste on aurait besoin que tout le monde s'assoie pour le protocole sanitaire. Merci beaucoup. Hello, good evening. My name is Colin Droxler and I'm the CEO of the EPFL Rethink team. We are honored to have you here today and to celebrate the 2-year process during which we have accomplished so much. The Formula Student is an engineering competition created in 1981, which take place all over Europe. From dynamic to static events, we are delighted to go to 3 competitions this season: Formula Czech Republic, Formula East, and Formula Switzerland. The Formula Student is a great opportunity for all of the students to participate in such a prestigious experience. Ross Brown, the F1 technical director, said one day that the only remaining innovative field for the automobile competition are the Formula One and the Formula Students. All of the 60 students are aware of the privilege to be part of such a great experience, especially after this challenging year. We all come from different backgrounds and from different sections of EPFL, from mechanical to architectural engineer. Everybody brings their own 2 cents to the team. Some of the members are here since the creation of the team, and some are brand new. But we pay a particular attention that the knowledge is sustained over time, and the alumni are never very far from the team. The team is also about good time and friendship. It was a difficult year due to the pandemic, but the construction of the car made it easier to go through it, permitting us to meet and collaborate and be able to see our little baby. All of this will not be possible without EPFL and all the workshops made available to us. So thank you to my teammates, to our school, and obviously our sponsor. So please allow me to introduce the Vice President for Education, Pierre Dillembourg.
Bonsoir. Bonsoir, mesdames. Vous m'entendez? Très bien. Bonsoir, mesdames et messieurs. Good evening, ladies and gentlemen. It's a pleasure on the behalf of Martin Vetterli, the president of EPFL, to welcome you here. As it has been told, I am the vice president in charge of education, so I'm delighted to see this kind of project happening at EPFL. Some of you have been working for credits, some not for credits. We want to increase the number of credits. We want to increase the passion. Being EPFL, it's not only suffering in difficult courses, it's also we want to have more passion in the curriculum, so we will increase actually the number of projects in the curriculum. And I would like also to give special thanks to the professors who have been taking care of the teams and the people in the workshops. Now, talking about pedagogy, when you talk about Formula One, is a bit boring. So I thought maybe you would prefer me to talk about why the bodyguard of Michael Schumacher almost killed my dog. True story. True story. My son was at school with Mick Schumacher, the son, who is not driving, and he had a bodyguard all the day long. Then we invited him for the birthday of my son, and we opened the door. There was a big dog, and the bodyguard almost shot at my dog. So, true story, but it's not over. Then we were invited to the birthday of Mick Schumacher in the village, in the villa of the Schumacher in Gland. And I said to my son, we stop. I need to take some fuel. So I took some fuel. And who was taking fuel next to me? Alain Prost. This is not a joke. I will not invent that. So this is a bizarre country. Then I decided to move to another village and we have a very narrow street in the middle. You cannot drive fast. We put 30 kilometers per hour. And who lives there? No? Sébastien Loeb. And Sébastien Loeb has to cross my village 30 kilometers per hour, and he does. So that's a more interesting story than maybe that pedagogy. Next year, if your project continue, I will tell you why I did not want my daughter to marry Lewis Hamilton. Thank you.
Okay, thank you. Okay, you can hear me well. So my name is Julien Delille. I work for the Vice Presidency of Education alongside Professor Pierre Dilembourg. And I'm actually going to talk about a little bit about pedagogy, so I hope it's not going to be too boring. I'm the coordinator of the MAKE program, and I would like to take the next few minutes to introduce you what is this program and what is behind this program. I will use the prototype of last year, so it's not a spoiler. Orion, which is at the entrance of the building, actually, to illustrate what is a MAKE project and what is behind this kind of project. So you have seen the whole picture on the slide before, many different student projects. So the MAKE program is an initiative supported by the Vice Presidency of Education. And the main objective is to give the opportunity to students to realize a project from A to Z. And by doing so, learn by doing, so reinforce what they have seen in class, but also develop all sorts of skills like project management skills, working in interdisciplinary team, communicate with students from other disciplines. All these very important competencies for their professional lives that you cannot necessarily develop in a classical course. To reach these objectives, we have two key elements that I would like to illustrate tonight. The first one is, it was the slide before, but it's the academic environment. We have many different research laboratories at EPFL and professors involved in coaching the students, supervising them through credited projects. And this is very important when it comes to developing the concept of the car. And the second key element at EPFL is the resources, so all the people and infrastructure that are crucial, very essential for this kind of project to exist. And here we have coach in prototyping that the students can see, meet, ask questions, discovery learning labs, student creativity and innovation laboratory, which are dedicated to education, makerspace, but also professional workshops when it comes to realizing more complex elements of all the subsystems of the car. I think this year, this project, they used all the professional workshops of the school. There are like probably 10 of them, so it's a good example. So yeah, those are the two key elements of every MAKE project, and we hope to give this opportunity to increase the number of projects and have more and more students in the future taking part of this kind of adventure. I already talked a lot. I will let the floor to Professor Mario Paolone, who is the main professor supervising the project. And I just would like to thank the students for their huge motivation and energy. It's really inspiring. And I'm looking forward to see the car. Thank you.
Good evening, ladies and gentlemen. Being an EPFL professor gives you several privileges. The first one is to carry out top-notch research, to train, to forge the next generation of engineers and researchers, and if you're interested to do, also supervise projects like this one. I'm not new to this kind of supervision, as I have been involved in the past with other projects. And what I can tell you is that there are always the same ingredients when you work with these students. Competence, passion, team spirit, and the wish to develop devices like this one that are a leap forward in technology. The statement that was said at the beginning regarding the two most innovative sectors in automobile industry, Formula Student and Formula One, actually is not a joke. And if you look at the difference that this car presents with respect to the previous one, actually they are day and night. The students that have been involved in the design and construction of this new car have taken a completely different approach, which is really bottom-up, from modeling to manufacturing processing to assembly of the various components. Don't forget that a car of this complexity is a system of systems that requires several gears to be coupled together to solve several optimizations related to the structure of the car, its static and dynamic behavior, suspensions, the braking system, aerodynamics, the traction system, the battery, the control, the telemetry, and all this has to be thought as a single body. And it's not only a MATLAB exercise, because eventually you have to build it and make it running for real. And today, here we are, with the results of several months of work. What I can tell you is that, and with this I wanted to close my speech, the competences and the passion of our students are really unique. These guys can spend countless amount of hours on top of their usual duties they have as a student. So don't forget they have exams to pass, courses to attend, and all they have done to produce this device is on top of everything. So they are working literally during the night to accomplish these results. So please join me to give a warm applause to these guys for what they have achieved so far. Thank you.
So again, many thanks to Julien, Pierre, Mario, and to all of our other supporters here at the EPFL, the administration, the workshops, and all of the people who help us and believe in us. In addition to the support that we receive from our academy, we are very proud to partner with companies experts in their field from Switzerland and all around the world. Thanks to your support, we are able to each year improve our race car, design some new innovative concepts, and travel around Europe to show to the world our work and dedication. The Formula Student competition gives us each year an amazing managerial and engineering challenge to design and build a race car in under just 1 year. Here at the EPFL Racing Team, we have more than 60 people working day in and day out on trying to solve this puzzle, either on the technical aspects or on matters such as logistics and sponsoring. We now look like a small company composed of 9 divisions that you can see here. We have the chassis, vehicle dynamics, powertrain, aerodynamics, electronic, BSS, which stands for battery energy storing system. We even have some nice and fancy acronyms. We have the business division and our latest division, which you'll hear more about in a few minutes, driverless. And finally, of course, our committee. Each day, one of the people from one of those teams uses the tool that you provide us to take on one of the many challenges provided by the Formula Student Adventure. Thanks to your help, we this year had the opportunity to really focus on research and development, to test, try out, experiment, and learn all year long. Because of this, we were able to make a big step forward to try and catch up with the teams that have been in the business for years before us. And so this results in our newest and hopefully best race car right under this veil that you'll be able to see in a few minutes. But we also were able to make some big progresses on the manufacturing side, using top-of-the-game equipment, softwares, and tools, as you'll see in a few moments with our CTO, Felipe. So, without your help, none of this would have been possible. We couldn't have built such an amazing prototype. So we want to use this special occasion to thank all of the people and all of the companies who helped us during this amazing adventure. So in the name of the EPFL Racing Team, I would like to thank all of our material and financial sponsors. I'd like to thank the EPFL. I'd like to thank those who manufactured some parts for us, those who let us use their softwares to develop our race car. I want to thank also those who provided help with logistics, those who provided some expertise, and finally our friends and families, which have been after us and supporting us all year long. Without your help, again, none of this would have been possible. So let's please have a round of applause for all of the people supporting us. Thank you. It's also really important for us to have a close link with the industry that's close to our passion. By letting us interact with the latest technologies, you help us to prepare tomorrow's engineers to arrive with a luggage full of useful experience and useful knowledge. And in just about 2.5 minutes after an amazing video, you'll be able to see our new race car, codename Mercury. So thank you. I'll let you enjoy the video, and I'll see you in 2.5 minutes. Thanks. Ok les gars, le châssis est là dans 40 minutes.
First, I would like to introduce you Mercury, the second car of the EPFL racing team. Good afternoon, ladies and gentlemen. As Colin said, today in front of you, you have 2 years of hard work from a group of motivated students. My name is Felipe. I'm in charge in the engineering and development of this car on this team. So let me give you an insight of my mind. I couldn't find the sports cars of my dreams, so I built it myself. So did Ferdinand Porsche. This is a picture that I would like to share with you. I would like that you pay attention to the hour and the date. Sorry, I'm going to take this out. To the date, and it was like just a few hours ago. So yeah, the car was in process of building like 5 hours ago. So yes, I'm very happy, and I had very good moments with this team. Designing the car, constructing the car, discussing about multiple multiple choice that we need to make in order to have, what you can see here. So I'm very happy to share with every team member every day and see how they evolve every day and how they learn each day. It's just impressive. It's very nice how this kind of projects could make you learn that the life after your studies in engineering is not just like classes in a classroom. This can make you learn a lot more. And from every team member that you will meet later on, he can tell you many souvenirs, many good or maybe bad souvenirs about many things that we lived overall this year. And yeah, he will tell you that with a smile in her face. So I invite you to share with them the much as possible. They are here for you. We are here for you. And Mercury is here for you. If we talk about Mercury in a small technical review, well, a car have multiple subsystems, quite complex. In first point, I would like to point out what makes the link between the ground and the car. And this is what we call, in general, vehicle dynamics, who has a responsibility in order to transmit and all the ground to the car and how it's going to attach to it. So the team vehicle dynamics need to develop many components in order to attach the car to the ground the best as possible. And this is a big challenge, because a car is the only way as a car attached to itself to the ground, there are just 4 patches. And this is just impressive. The wheels are clearly part of this division. We can see here the wheel assembly. But now we have wheels. Then we need to power the car with something. We need motors. So this car has the particularity to have 2 engines, 2 synchronous engines, that doesn't have any mechanical link. So we have that the 2 rear wheels of the car are completely uncoupled mechanically. So in this case, we need that the electronics team and the control team make a good development in order to control those motors, in order to send the maximum power and the maximum torque, or the torque that we need at each wheel at the good moment. And this is a very hard and long work that need to be implemented and tested. Afterwards, we need to test the things. Afterwards, to can run the motors, we need to extract the energy from somewhere. So here we use a battery that is completely manufactured by us. We bought the cells, but every structural item that you can find in our battery is completely manufactured and designed by us. What is a clearly big challenge, because there's no space. There are very little parts that need to hold every single component, every single cells. And this is a high-level challenge that can be made by one of our engineers. They are completely capable to do it, and we did it. Another interesting point is the use of the composites. Today in race car world, we can see that every car we are hearing about carbon fiber and different other types of fibers. In this case, we used an interesting mist for some components, and this is a point that I would like to point to you, and is the use of flux fiber, a sustainable fiber that is kind of an alternative for the carbon fiber. Here, as you can see at the right, we have a sample, for example, that is just the mist of carbon fiber with a kind of matrix that in the mist at the end reaches a piece that is very lightweight and with a stiffness is good, considerable. And this is how we made our bodywork, for example, or our seat that has also that kind of technologies that is used today by other car manufacturers in the world. So here's Mercury, our second car. I would like to give a special thanks to all the team members that work in this car. They worked very hard, and they just give all of the things that they have inside of them. They have good memories, good remembers of what we did. But however, I would like to say that this car was started like 2 years ago. The blueprints of this car were stated like by a 2020 team led by Pierre, Georges, and Marc Delesalle. This is how this second car started. So I would like to give to him, to them, and to the 2020 team a personal thanks for the work that they done. And yeah, what I want to say to finish it here is like, enjoy the rest of the evening, enjoy the car, enjoy also Orion that is outside. We can see what changes between two different concepts. It's very interesting to pay attention to the details. But enjoy the evening, enjoy the team members, and enjoy the cars. Thank you very much. I will let you with Alex, that is our head of driverless division, that will explain to you what is the next step in future years for the EPFL Think Racing team. Thank you very much, and have a good evening.
So, the next stage for us at the EPFL Racing team is to go driverless. With the constant wheel of pushing innovation further and pushing students to experiment with new technologies, Formula Student decided to narrow down the number of categories accepted in competition down to 1. Up to now, we had the combustion category, the electric one, and the driverless one. And from 2022 onwards, everything will be electric, and the same car used for the electric events will also be used for the driverless events. At the EPFL Racing team, we saw this as a chance to actually join in on this new adventure and to launch our own driverless program. And we're really excited to actually tell this news to you tonight. We decided to go for a 2-year strategic development plan in which we do not only want to make a working prototype, but we actually want to compete, to be able to compete against the other teams that have been doing this for longer than we have. We're doing this by leaning on the work that our labs have been doing at EPFL and through bachelor and master projects supervised by professionals of the industry. And this will help us to accelerate our development at the moment. For our second year, we want to improve what we've done this year and to actually try and implement everything that we've done on Mercury before December 2021. Then we will run some tests on this car to check for the safety and for its ability to pass the different tests that we have to do it, so for the different events. Once we're happy with the results, we'll move on to next year's car, and that work will start in March 2022. Our goal at the team at the moment is to take part into the straight line acceleration event in 2022, so next year. Once we've done that, in 2023, we want to take part into the skid pad event. The skid pad event is just an H-shaped circuit, and the car has to drive around it to test for lateral acceleration. Finally, our main goal for 2024 is to take part into the track drive event. So we just want to put the car in a circuit that it has no knowledge of, and it has to drive around it as fast as possible. The fastest lap gets the most points. To do this, we rely on multiple sensors, the main one being the camera, of course, but we've also started working with extra sensors within the EPFL Racing team, one of them being the LiDAR. The LiDAR allows us to estimate pretty precisely the distance of objects to the car, and this allows us to give more robustness to the vision of the car, and the vision is really the basis to have an efficient and a fast driverless car. Our goal at the EPFL Racing team is not only to make a working prototype, we also want to look for new solutions, and we want to drive innovation forward. To do this, research is at the core of our methods, and that's really something we're passionate about, because we do not want to just do what everyone else has done already. We want to really innovate, and we want to win with this car. Given the importance to fight for a better and a safer future, we want to help build an innovative and sustainable technology And at EPFL Racing Team, we're really excited about this next chapter, and we're definitely looking forward to be sharing with you our progress in the months to come. So that was it for us tonight. I'll just ask everyone to remain seated, and the team leader will come and get you by groups of 10. Thank you very much for being with us tonight, and I'll see you outside.